Say hi from Cherish Math. This is the question. A quarter circle, a semicircle, and a circle are inscribed in a square with 1 unit square and are tangent to each other. As shown in diagram, find the area of the blue circle. I'm going to draw the first triangle connecting from the center of the quarter circle to the center of the semicircle, and it is at a right angle. Let the radius of the semicircle to be R2, so the radius of the quarter circle, it is 1. And for this width, that would be 1 minus R2. For the beginning, I need to find for what is the value of the R2. And I'm going to use Pythagoras theorem to solve the problem. This is the first step. And by expanding it, this is cancel and this is cancel. By rearranging the equation, 4R2 is equal to 1 and the value of the R2 is equal 0.25. Let me keep the value of the R2 here, and I have to clean up the workings here for the next calculation. I am going to create 2 more triangles here, and both of the triangles are at the right angle. Let the radius of the blue circle to be R1 and the radius of the red semicircle to be R2 as it was named earlier. And now I'm going to name each part of the length. For the radius of the quarter circle, it is 1. And I'm going to name for the length of this part to be y, and for the length of this part, that will be 1 minus y. While for this part, that is going to be 1 minus r1. For the length of this line, it is r2 minus r1. By using Pythagoras theorem, I'm referring to the triangle in the red color, and the first equation is formed. From this equation, I'm going to expand the whole thing. R2 square is cancelled. R1 square is cancelled. Rearranging the equation, and the next step, I will try to substitute the value of the R2 that I got it from the earliest working into this equation. And this is how it looks like. In the next step, I'm trying to get R1, the subject. And this is R1 equal y squared. The next working is going to use up the same Pythagoras theorem on the green triangle. And this is the beginning. I'm going to expand this equation. This is cancel. This is cancel. And I'm going to rearrange this equation. And on this equation, I'm going to substitute the value of the R1 from R1 equal y squared. This is the substituted value. And I rearrange it again. Now, I'm going to do factorization on this equation. This is how it goes. The value of the y is 1/3 and -1. Since for the value of y, it doesn't exist in negative. So the only one that I'm going to pick up is 1/3. I am now at the final part of the working. To find out what is the value of the R1, I have to substitute the value of the y, which is 1/3, into this equation. That is going to be R1 equal 1/3 square up the whole thing. And the value of R1 that I'm going to get here is 1/9. So the area of the blue circle is going to be pi R1 square. Once I substituted the value of the R1 into this equation, and I'm going to get 1/81 pi for the area of the blue circle. And I solve the puzzle. Thanks for watching and please subscribe.